Welcome back to Wildcat Academy. Today we'll be working a few examples of rational expression applications. In example 1, we're asked to find a simplified expression to represent the area of the rectangle below. The area of a rectangle is just base times height or length times width. So we can take the two expressions, x squared minus 9 over x, multiply times x squared minus 4x over x squared minus 7x plus 12. And that's the way we will set up our problem. And then we just have a rational expression of the multiplication problem to simplify. So we will factor everything that we can. So we'll completely factor the numerator, denominator of the first fraction, and then completely factor the second expression. And then we'll cancel common terms. So we will cancel the x and the x, or divide them to be 1, the x minus 4 and the x minus 4, the x minus 3 and the x minus 3. And we end up with x plus 3 as the simplified expression for the area of the rectangle. In example 2, we're asked to find the width of the rectangle. So the area of a rectangle is base times height, or sometimes it is phrased in terms of length times width, as in this example. So the width of the rectangle will be the area divided by the length. So the width will be x minus 9 over x divided by x over 3 plus 1. We have a complex fraction that we must simplify, so we'll multiply all the terms by the common denominator of the smaller fractions, which in this case is 3x. So 3 times x and 3 times x. Every term will be multiplied by 3x. And then we will just cancel the x's. We'll cancel the 3's here, and then we'll rewrite our expression as 3x squared minus 27 all over x squared plus 3. We will then rewrite our expression as 3x squared minus 27 all over x times x is x squared. 1 times 3x is 3x. Alright, so we'll want to factor and cancel and simplify this remaining expression. Let's scoot our problem down there just a little bit. And we want to factor out a 3 GCF in the numerator and get x squared minus 9. And then we will factor that one more time and get 3 times x plus 3 times x minus 3. Completely factor that numerator, and then we will factor the denominator out. Factor out the GCF of x, and you get x plus 3. And then we'll just cancel our common term. So our common term here will be x plus 3, and then we'll rewrite everything else as our solution. Our finalized solution in this case will be 3 times x minus 3 all over x. So our width is 3 times x minus 3 over x. In our third example, we're asked to find a simplified expression for the area of a triangle. So we're using a different formula. We're using the formula for the area of a triangle, which is area is equal to 1/2 base times height. And then we'll just plug in for the base and the height and simplify that expression. The base of the triangle is x squared times y over 6x cubed y squared, and the height of the triangle is 48x to the 5th y cubed all over y to the 4th. So now we'll just simplify this expression. In this particular example, we could cancel a little bit at a time and cancel across the numerators and denominators. I think it's going to be easier for us to rewrite the problem after having multiplied everything out, since it is monomials and there are 3 terms. I think it'll be easier to see. So we're going to do 1 times 48 is 48, x squared times x to the 5th is x to the 7th, and we get y to the 4th in the numerator. And then we will end up with 12 x cubed y to the 6th. It's not necessary to do this step, but I do think it makes it easier in this particular problem to see. And then we'll divide 48 by 12, which is 4 over 1. And then we will cancel x cubed, the x to the 7th, and get x to the 4th. We will cancel y to the 4th with y to the 6th and get y squared. So this ends up being 4x to the 4th over y squared. That ends up being the expression for the area of the triangle. If you found this video helpful, be sure to hit the like button below. Subscribe to the channel so you'll be notified the next time that we release a video, and leave any questions below. I'll be happy to answer those for you if you have comments or questions about how to simplify rational expressions or the applications of rational expressions.